All right, lesson 1.3 today. Good afternoon, class. Hope your week has been going well this week. So, as we take a look at lesson 1.3, we're going to take a look at a special type of geometric sequence. We call it a shifted geometric sequence, but I like to look at it as a combination of an arithmetic and a geometric. It's basically we kind of like put them together. So that's why I wrote the word combo here, and I kind of kept this up here for today just to make things a little easier for myself. So how a geometric sequence works is you still have this u sub n equals u sub n minus 1 part. So I'm just concentrating on the recursive piece. You'll always have u sub 1 or u sub 0 equals some number. Okay? So what happens is you're going to multiply the previous term by some value and also add some common difference to it. Okay, so you're going to multiply first and then add or subtract. So what's really neat about this is these problems, this geometric sequence, really relates to many practical situations, and you're actually going to see a couple of them today. But this is something that I use personally in my own life when I think about putting money away for my daughter's college. I put a set amount, I add a certain amount each and every time, and it earns interest. And I do that every month. And so I can use this formula to help me see what the value of her account might be after a long period of time, which is really cool. Speaking of that, long run value. So long run value, sometimes these geometric sequences will just keep growing and growing, get bigger, or smaller and smaller. But many of the times you'll have what's called a long run value. It limits. It will go to a specific number. So many shifted geometric sequences, and it happens when this R value is basically between 0 and 1, will approach a certain value over a period of time. It levels off to some number because the amount you're adding in equals the percentage that is being taken out. And so it just kind of hits a certain number. So to give you some situations where this happens and how we can have geometric sequences. We start off with this first problem. Love this first problem because, as I've shared with you before, I used to be a swim coach, and one of my jobs I used to do was for 7 years I worked out at Wayzata Country Club, and I taught swim lessons. But on the weekends, they asked me to do the maintenance on the pool. So I'd actually drive out early in the morning, 5 o'clock in the morning, get out there, yes, on a weekend of all things. Way to spend my weekends. But then again, as a teacher in the summer, my weekdays are like weekends. Anyway, I would have to maintain the chlorine levels on the pool, clean the pool, and everything. So this is, something that we in essence would do. So in this problem, it says the Osborns have a small pool and are doing a chlorine treatment. They'll initially provide a shock. So like when we started the pool, we would dump in a lot of chlorine. And when we do that, the chlorine levels are super high where you don't want to swim in it. If you actually jump in, it could actually hurt your eyes. It could actually destroy your clothes after it would basically change your clothes different colors after a while. And sometimes it would just erode them after a few days if you let them sit in that high chlorine water. Anyway, so we have this shock treatment. Then they add a small amount each and every day after. The amount of chlorine is measured in grams. The recursive formula that models their treatment is this. So we got all this numbers here, and I want to kind of explain what these numbers actually represent. This 300 represents 300 grams of chlorine added as the shock treatment. So what they did was they added 300 grams of chlorine in their pool initially. Boom, they dumped that much in. Okay? Then what happens is each and every day, okay, the pool loses 15% of the chlorine. So what happens is, like when I'd be out at Wayzata Country Club, kids swim in it. So the chlorine is helping kill the bacteria and such. Likewise, evaporation happens and the chlorine levels go down. So what we have to try to do to maintain a consistent amount is we have to add, so we are adding 30 grams of chlorine each day. In fact, we had a machine downstairs that we would set, and it would actually pump in, okay, just like a drop of chlorine every like 30 seconds into a big filtration system so that it would keep the level going. Okay, and so in essence, that's what they could do here. Okay? So now, what it asks us to do is to determine what happens to the chlorine levels in the long run. So this is where we're going to use our calculator to help us out. So I'm going to go back to my y equals. Okay, remember that value up here is this, that 0 is the same thing here. The bottom number, remember how yesterday we were doing $500? This bottom number is my starting value of 300 right there. So I'm going to change that 500 to 300 because I'm having 300 grams of chlorine. However, everything on this equation changes. Now what I like to do is this comes second. So I know the old notes had this first, but this should actually come here. And I keep the use of n minus 1 the same. So what I do is I move my cursor, and then I'll say times, and then I need it to say 1, and now I got to change that to minus 0.15, and I need to close the parentheses. But then I need to add 30 after it. Now I have that extra parentheses, so you want to hit the delete button to delete that. Always delete, don't clear, because if I hit clear, then I got to type it all back in, and then I got to remember, how do I enter in the U? Second 7. How do I get the N? It's right there. Okay? So if you ever do that, it's okay. Go back, review to see what happens. All right, so now I'm going to go to my table set, and the reason why I go back to my table set is it's set at 104 days. I don't need to necessarily see how much chlorine's in it at 104 days, plus it might take a long time. So I'm going to start it at 0, start to look at it, and you can see that initial shock, lots of chlorine. I probably don't want to have that much chlorine. That would probably do some, that could hurt someone, whether it burns their eyes so bad that they could actually, if it's too much, you could actually go blind. But you can start to see after several days, the chlorine level is getting lower and lower and lower and lower. And it looks like it's getting closer to about, it looks like it's going to 200 grams of chlorine. Okay? And it does get smaller and smaller. In fact, if you want to go to the table set and say, all right, well, let's go to 100 days. Okay, go to that table. This is why entering 100, you can see, all of a sudden it just says 200. Now, technically, it's 200.00000. So it's getting smaller and smaller and smaller. But in essence, it's going to 200. So now, it asks you to calculate out the long-run value algebraically. So, if you're okay with this, this is how I've taught this before. I like to abbreviate long-run value as LRV, long-run value. Okay? So, how you calculate out the long-run value? It's a simple formula. You just simply take the adding amount. So, how much are you adding? And you divide it by the percent of decrease, meaning how much are you losing percentage-wise? Okay? So in our case, and you can do this for all the problems, we're adding 30 milligrams. Okay? If I divide that by 15, what it will tell you, in essence, right, is where it's going to actually level out. It's basically saying 15% of what number is actually 30. Okay? So you go 30 divided by 0.15, and that number, lo and behold, see how they matches up. 200 grams. They match up. Okay? And again, that's kind of the whole thought is you're thinking about 15% of what number is 30. So if you just simply divide these two, you'll get that number, and that's what you're looking at. All right, number 2. Okay? So number 2 is also very important. Sometimes some of you have, unfortunately, got an infection. I know one time I cracked a tooth and it got infected, and I was here at school, and my whole side of my face was starting to swell up, and I had to go get the tooth removed, and I was given antibiotics. And one of the things they told me with the antibiotics, with the medication, is I had to take them, even when I felt better, to take them until they were gone. There's a reason for it. And the reason for it, again, is this whole concept of this long-run value. They're trying to get a certain amount of antibiotic in my body at a certain level. Okay? So let's take a look at an example here. It says a doctor is going to prescribe the drug Fusporin to a patient. I don't know if that's an actual drug, but anyway, the doctor knows that only 10% of the drug is cleared from the blood by the liver and kidneys every 8 hours. Suppose also that the drug works best when the total amount in the body is exactly 1,000 milligrams, 1 gram. Okay? Initially, the doctor decides that a patient should take 100 milligrams of Fusporin every 8 hours. So I know it works the best if you got 1,000 in the body, but maybe your body can't handle so much at the same time, hence why it subscribes 100 at the same time. So it says, write a recursive rule for this situation. So we start off, the doctor says, okay, you take 100 milligrams. Then U sub n equals U sub n minus 1. So now the body gets rid of, or it clears, 10% of it. So it's going to get multiplied by the 100% minus 10% as a decimal, 0.10. So I'm losing some of my medication, but after 8 hours, it'll probably say take 3 times a day. I take another pill. Okay? So now I'm going to type this in my calculator. I'm going to go to my y equals. Okay? So this bottom number down here is 100, because that's how much I'm going to start with. Take an initial dose. Okay? So I go up to my equation. Whoops. I'm jumping around here. And now I want to write it as 1 minus 0.10. But instead of adding 30, I'm adding 100. So what's nice is I actually didn't have to delete anything out on that one. All right, so I got it in my calculator. So now the next question says, determine the level of medication in the blood after 2 days. It says, careful, this won't be 2. So think about 8 hours. 8 hours is kind of the same thing as saying 3 times a day. Because 8 plus 8 is 16, plus 8 is 24, 24 hours in a day. So for 2 days, I really want, in this problem, I don't want U sub 2, I want U sub 6. So now, we'll go back to my table set, because I was at 100 from the swimming pool problem. And I want to change that table set to 0 for right now. So I go to the table, should pop up pretty quickly, and I can start to see now is after 2 days, all right, the amount of antibiotics of Fusporin in my body is up to 521 if I just go 7 milligrams, not grams, sorry, milligrams of Fusporin in my body. Okay? So now the question becomes, did the doctor prescribe it right? Did he get me up, will he eventually get me up to 1,000? Whoops. So I'm looking for the long run value. So the adding amount is 100. My body is taking out 10%. So 100 divided by 10%. Look at that. And I eventually, the long run value is 1,000 milligrams. In fact, if I go back to the table and I start scrolling, you'll start to see that, wow, after it keeps on getting bigger, but it's getting, much closer to, or it's getting closer and closer to 1,000 there. Okay, so sometimes they'll give you like 1 week or 2 weeks, and they ask you to take it for a long time. I think for my tooth, I had to take it for like 2 weeks. So just to make sure that it killed out any infection. So, all right. Continuing this problem on the back page, example 2, it says, now suppose instead the doctor prescribes a loading dose. So what actually happened to me was when I went to the doctors and they pulled the tooth, he actually gave me a loading dose. He made me take actually a couple pills of the antibiotic right away. And then I only had to take like one every, I think only in the morning and the afternoon. I'm trying to remember exactly. But I just remember he gave me a loading dose right away. So here he says, suppose instead the doctor prescribes a loading dose of 1,000 milligrams taken initially, then every 8 hours the patient only takes 100 milligrams. So now it's asked you to do the same thing, write that recursive rule. All right, so now u sub 0, instead of being 100, becomes 1,000. However, the second statement, u sub n minus 1, that doesn't change. 1 minus the 10%, but plus the 100. Okay? So it says, determine the level of medication in the blood after 2 days. So we want to see what happens at u sub 6. This is actually pretty cool. So let's go to my y equals. The only thing that changed on this problem is that instead of starting with 100, the doctor gave us what they call a loading dose. Okay? All right. So now when I go to the table, now it's probably going to think that there it is after 37 days, but let's see where it is after 6 days. Look at that. It's at 1,000 every single day. Because if you think about it, 10% of 1,000 is 100. So 100 milligrams is removed, and we're adding 100 milligrams back in. So what's really cool is here it gets to it right away, and it maintains it right away. So here it says compare the two approaches. How are they the same? How are they different? Well, if I look at this, the main difference was the starting value. Okay? The amount we started with was different. However, there is similar in that you do level off where the long run values was 1,000 for each. It says which one should the doctor utilize? Honestly, it all depends on the medication. Can a person handle that loading dose or not? Okay. All right, that's all we have for the notes today. It's pretty short and sweet. Go ahead and work on the assignment worksheet if you get stuck. I know we just did a few example problems, but it's going to kind of entail some of the stuff that we did in the past too. So if you get stuck, watch the video or let me know, and we'll do our best to help you out. Have a great day.